17. And we have so we have one problem yet to go in this little section. So who remembers what we do, Geo? I factor it. So when you say factor it, we can actually factor this one by grouping. So what can we take out of the first two terms? We can take out a 2x squared, okay? And what will be left? Be careful here. If we take out a 2x squared, we're gonna have x minus 1, good. If you take out the whole thing, don't forget to put the 1 in there to hold that place. All right, now what can come out of here? These last two. Negative 8. Now remember, if you take out the negative, it's going to make this term positive and this term negative. So that's going to become negative 1. Right? Well, look, we have a common factor, so we write it down. And then everything else, there's the common factor, I wrote it down. Everything else is in the next parentheses. Now, what do you notice about that last parentheses there? What? Well, it's got a squared in it, but what about this? We can take out a 2. And my numbers, I'm used to seeing them out in front, so I'm going to pull that 2 clear out here. That 2 is coming out here. And if I take that 2 out, what's left? If I take a 2 out of here, x squared minus 4. And what's special about x squared minus 4? It's the difference of squares. So we have 2, then we have x minus 1, then we have x plus 2, x minus 2, the difference of squares. Okay, now we have to sketch it. That was our job, to sketch it. So, how do I go about sketching it? Now that I've gotten it factored, how do I go about sketching? I put my x-intercepts or my dots on the x-axis, and they're going to be at 1, -2, and 2. And I label those 1, -2, and 2. This is an x cubed problem, right? 3 x's. Where do x cubes and any odd x's start? Down. They start down here. Remember that when you hit a dot, sometimes you go through and sometimes you bounce off and make a little parabola thing. What's happening in this problem? We're just going through. Because what do we not have? Don't have any squares. So we just go through the point, connect to the next one, go through the point, connect to the next one, go through the point. And there is a picture of your curve. So 2.3 will be due, that's the end of 2.3. 2.3 will be due on Monday. Okay. You want to get that done and turned in tomorrow? That would be great. Or you can turn it in Monday. All right, let's look at the next problem. Can anybody tell me what's a little bit different about it? So it looks the same. Notice anything about it? What did we do in the last one we just did? We grouped it, right? Okay, does this one group? Now, you can take stuff out. For example, I can take an x squared out of the first two, and I can take a -1 out of the last two. But what doesn't happen when I do that? I don't get a matching parentheses, and when we factor by grouping, you have to get a matching parentheses. All right? So this is the exciting part now. We need to factor this somehow, but it does not factor by grouping. Grouping doesn't work. So we need to figure out another way that it factors. Now, what do I mean by a factor? When I say 5 is a factor of 10, what does that mean? It goes into it evenly with no remainder, right? So what I need to do, if my job is to factor this, I need to find a number that will go into that evenly and not leave a remainder. To do that, I'm going to do something called synthetic division. And I know that you learned how to do synthetic division last year, but you haven't done it since then, so maybe you're a little shaky on it. When I'm going to do synthetic division, I am going to divide, or I'm going to write down all of these numbers with the negatives. And then in a little box out here, I use a box, I'm not sure what you guys used last year, that out here to the side, I'm going to pick a number and I'm going to divide. Okay? Now, pick a number. Keep it small. How about, I'm going to divide, yep. Let's just use 1. Let's just try 1. So when I do synthetic division, okay, let's pause a minute and make sure you're clear on what I'm doing. My job is to factor this. It doesn't factor by grouping, and that is the only way I know how to factor. It doesn't factor by grouping. So I know that a factor is a number that goes in and leaves no remainder. So I am flat out guessing a number that I'm going to divide in and hopefully get no remainder. So to do that, I'm doing synthetic division. So I just randomly pick 1 because it's an easy number to do. When I do synthetic division, whatever this first number is, I bring it straight down. Is this looking familiar? Then I take 1 times 1 and write the answer here. Then I add. Then I take 1 times 3 and write the answer here. And I add. 1 times -2, write the answer here, and I add. Oh, shoot. Do you remember that when you do synthetic division, the power in the answer goes down by 1? So this is like 1x squared plus 3x minus 2. And what's that guy right there? He's the remainder. That's the remainder. And what was I hoping would happen? I was hoping to get a 0, no remainder. So what did I just discover? I discovered that 1 is not going to be one of these. 1 is not going to be a factor. Okay? This picture is left over from the last time. But I'm looking for these dots right here. See how it's 1, 0? That's the remainder right there. That's the number you get. And I want that to be 0. Okay, so what am I going to do? Pick a different number. Now I know what you're thinking. You're thinking, oh my gosh, this could take forever. Yeah, I'm going to give you a couple of hints, but there is no other way to do this. There's not like some magic pill. This is how we do it. We just got to pick another number. How about 2? Let's try 2. So 1, 2, -5, -6. All right, let's walk through this one again, and then maybe you'll try the next one on your own. Remember, these are the numbers from the problem. Bring the first one straight down. 2 times 2, or 2 times 1 is 2, write it here. And add. 2 times 4, write it here. Add. Oh, 2 times 3, 6. Add. There it is. We guessed one. We guessed one. So in terms of graphing, that means that 2 is one of my dots. Because when I did the division, the remainder turned out to be 0. What's left here? Look, just like we did over here. What's left this time? What's that? X squared plus 4x plus 3. Wait a minute. Does that factor? That's a quadratic. Can I factor that like this? How does that factor? X plus 3 and x plus 1, perfect. So what does that mean? Remember, we were to graph this, we're graphing this. So where are my other dots? I guessed one of them. One of them was 2. Where are the other ones? -3 and -1. Yep. So, now I can sketch it. It's an x cubed. Where did we just say x cubed start? Down. So I'm going to start down here. Connect, connect, connect. How's come there's no parabolas, no bouncing around? Because there aren't any squares? Does the next one look kind of the same? So I'm going to give you a little bit of a hint because I totally get it. This could be a very long process. You might get lucky and guess right off the bat, but probably it's going to take a few guesses. So I want to narrow it down for you a little bit. You'll notice next to the problem, I have this thing called PRR. PRR stands for possible, rational roots. So possible. When you are just randomly guessing numbers, remember in the last problem I guessed a 1, didn't work, and then I guessed 2 and it did work? When you're randomly guessing numbers, the possible rational roots will become your possible guesses. So you won't just randomly be picking numbers out of the sky, you'll be picking them from this pile. Now how do you get this pile? Well, you take factors of the constant. And by constant, we mean the one with no variable. This is called the constant. The term in the problem with no variable. And you divide that by factors of the leading coefficient, which for us is just 1. That's good news. So for this particular problem, my guesses, these are my possible guesses, my possible rational roots, my possible guesses are gonna be factors of 6. Well, what are the factors of 6? Plus or minus?
2.
6, 3, 2, and 1. I'm gonna go in order there, but 2 is definitely a possibility. 6, 3, 2, and 1, those are the factors. So, when I say, Sydney, pick a number, she is gonna pick a number from this list. She isn't gonna pick 5. She isn't gonna pick 7, not 4, not 10. She's picking a number from this list. Now, the good news is, the leading coefficient is just 1. So that doesn't really impact anything. So here are your guesses. Only 8 numbers possible to guess, plus or minus those 4. All right, so on your own, would you see if you can guess one that gives you a remainder of 0? So this time you're going to be dividing into 1, -6, 11, -6. So guess a number from this pile, positive or negative, and see if you can get a remainder of 0. You want this last number right here to be 0. So everybody's trying this. See if you can come up with one. No one's found one yet? 3? Edgeny says 3 works. Now, are there other numbers that work? Yeah, there's 3 numbers that work. She just happened to be the first one to say anything, so I'm gonna start with 3. But you're fine. If you find a different one, that's totally fine. Let's see if Edgeny's right. So I bring my 1 straight down. 3 times 1, add. 3 times -3, add. 3 times 2, add. Very good. So, in terms of the graph, that means that one of my dots is going to be at 3. Now let's look at what's left. You could keep guessing, but that's going to take longer. It's easier to take a look at what's left. What is this now? This is what? 1 x squared. Remember, it started out x cubed. And when you divided something out, it goes down 1 power. So x squared minus 3x plus 2. Does that by any chance factor into what? X? I think they'll both be minus. Minus 1, minus 2. So where are the other 2 dots then on this picture? At 1 and at 2? You guys that were guessing, did anybody guess 1? Did it work? Yep, it sure did. Did anybody guess 2? It worked.
Question.
Mm-hmm.
Would it be different, like, points if we use a different number?
No. Because if you did 1 and you divided 1 out, then you're left with x squared minus 5x plus 6, which factors into x minus 3, x minus 2. So you get exactly the same dots in a different order. So this was an x cubed, no squaring going on or anything, so there it is. You guys, this is pretty powerful. You're kind of like, I don't know, out of it a little bit, but this is pretty cool stuff you're doing here. Because you're taking a problem that does not factor by grouping and you're factoring it. If they factor by grouping, you should always do that because that is going to be fastest. this does not factor by grouping. And again, I want to emphasize, because with a problem like this, kids will say, but Mrs. Ford, you can take an x squared out of the first two. Yep. And you can take a -3 out of the last two. Yep. But what has to happen? If we're going to factor by grouping, what do I have to have at this point? A match. No match means no grouping. Doesn't factor by grouping. So if it doesn't factor by grouping, that means I am going to have to guess and divide. Now, what am I going to guess? My PRRs will be factors of 18. So what are the factors of 18? 18, 9, 6, 3, 2, and 1. You can have those in any order. I usually do them in order because that makes sense to me, but these numbers can be in any order, it doesn't matter. And then divided by the leading coefficient factors, which is just 1 again. Now, that's a bigger list this time, but it's still better than infinity, right? That's what we had before, is whatever number. Now we got it narrowed down. So again, you guys try. Pick one and divide it out. So pick a number and divide it into this. So here's the setup. Erickson, go ahead, let's do this division. Where everybody's guessing, you too, Taylor. I set it up for you. Here are the numbers from the problem. You're gonna pick something out here from this list. And it could be positive or negative. Find one yet? Ruby, what'd you find? Two works. Now, again, as we just said with Gio in the last problem, you can find other things that work. I'm gonna go with 2 because she spoke up, so 2 times 1 is 2. If you're not sure how to do this, watch. 2 times 1 is 2. Add. 2 times 6 is 12. Add. 2 times 9 is 18. Add, and sure enough, she got it. She got it. Any question about the division? Who remembers then what we do after we guess correctly? We have a correct guess. Got a 0 here, no remainder. What do we do next? We write down the quotient, this is called the quotient, the part that's left, and what will that be? X to what power? Second, plus 6x plus 9. And then we factor that guy. How does he factor? X plus 3, oh, wait a second. X plus 3, x plus 3? Isn't that like x plus 3 squared? Now, why is that a big deal to me? Because I'm gonna be graphing, right? And what does that mean? We're gonna have a bounce off point there. So I got from, or Ruby got from guessing, she got 2. We got from our factoring -3, so we only have 2 dots, right? Because these two are the same. This is a cube, so it starts down here. But what does it do when it hits that point right there? That point came from this. So it bounces down, makes a little parabola there, and then comes back up and shoots up into space. Okay? All right, you ready for the good news? That's 2.4. So 2.4 we'll be due on Monday also. No, I can hardly stand all this excitement. All right, in a minute, I'm gonna have you guys come up and practice one of these, but first we're gonna do a little synthetic division practice. Just a little extra practice for synthetic division. So, we're not guessing here, they're just saying do a division problem. And there is something special about this that we need to make sure we talk about. Gio? What? Oh, shoot. Oh, I'm sorry. You're right. I turned my page and didn't pay any attention. All right, I'll leave that up there. We'll do that in a second. Okay, yeah, you're right. Here's one more to do. Thank you for keeping me on track. Okay. Can you tell by looking at this it's not going to factor by grouping? Yeah? So what are my PRRs? Oh, this is nice. What are my PRRs this time? Factors of, wait a minute, what are the factors of 7? Aren't they just 7 and 1? And then your leading coefficient is still 1? This is amazing. Because when you start guessing in order to divide, you only have 4 possible guesses. Plus or minus 7 and plus or minus 1. That's it. Those are your guesses. So, I don't know, what do you want to start with? I like 1. Let's start with 1. 1's easy. Start with 1. So 1 times 1. 1 times -8. Oh, yay! First guess. Look what happens. So that means that when I graph this, I'm going to have a dot at 1. Would everybody agree with that? That's your factor. That's your 0, your x-intercept. That's your dot. Now, what's left here?
X squared minus 8.
Plus 7? Does that factor? By the way, all of ours have factored, but if we ever run into one that doesn't factor, what do you suppose we can do with it since it's a quadratic? Use the quadratic formula, right? Okay, does this one factor though? I think it does. X minus 7 minus 1. That means there's a dot at 7. Does anything bother you? This says there's a dot at 7. This says there's a dot at 1, but didn't I already put a dot at 1? That's a squared. That one's going to be a squared because I already got a dot at 1, and this is telling me to put another dot at 1. So this is going to be a bounce. It's a double dot. Think of it that way, it's a double dot. So, comes up, bounces off, goes up. There is the graph. Now, that was a little tricky, that squared part. Does everybody understand what happened? When we guessed 1, which told us, and it worked, which told us we had a dot there. But then after we did the division, and we factored the quotient here, we got another dotted 1. Which means that factor happened twice. And when it happens twice, it means you have a little parabola there. Alright, so like I said, we're gonna do a little synthetic division practice, and we'll practice one of these at the board, okay? Alright, back to the synthetic division. Two things a little tricky about this. First of all, if we're gonna do a division, it says divide, so we're gonna do a division. We have to figure out what we put out here in the box. Okay? Now, I want you to think about what we just did. When we graphed that point right there, wasn't the factor x minus 7, isn't that what the factor was? And that told us to put a dot at 7. And when I did my division, and this was x minus 1, and when I did my division, I put 1 out here in the box. So if I am dividing by x minus 2, wouldn't the dot be at 2? Which means the number that I have to divide by is 2, because the number I divide by is where I put the dot. And if the parentheses is x minus 2, then the dot is a 2. Are you following what I'm saying? It's what you've been doing all along. Only now I'm pulling that number out, and instead of putting it on the number line, I'm putting it in the box. Okay. Now, when I write down all the numbers in the problem, so I start with 2, I have to be really careful. Do you notice anything right here?
0.
The x cubed term is not there, which means I have to put a 0. So this is my x to the 4th term, this is my x cubed term. Now I have my 3, which is my x squared, my negative 9, which is my x, and my 1, which is my constant. You will not get the right answer if you don't put that 0 in there. You have to put that 0 in. Everybody with me? So here we go. Drop the first number, in this case it's a 2, drop it straight down. Then what do? We multiply 2 times 2 and write it here. Add 2 times 4, write it here. Add 2 times 11, write it here. Add 2 times 13, write it here. Add. Keep an eye on my arithmetic. Is it okay? So what's the answer to the question? Be careful now. What's the answer to the question? You gotta put the letters back in. So what do we got? 2 x to the what? 3rd. Why is it x to the 3rd? Because it started out as x to the 4th, and it always goes down by 1. So 2x cubed plus 4x squared plus 11x plus 13, and what's that 27 on the end? That's your remainder. So we say plus 27 over x minus 2. What the remainder over what we divided by. Is this a factor? No, because the remainder didn't turn out to be 0. Any question about that? Okay, so what do we have to be on the lookout for when we do synthetic division? If we have a power, ooh, that's some kind of bug. If we have a missing power, we have to put in a 0, right? All right, next, let's do the next one. So we are dividing all right, what am I going to put in the box this time? Negative 1. In the box is going to go negative 1. And then across here is going to go 3, negative 7, 9, and 1. Do I need any zeros this time? Nope, because everything's there. They go right down in order. All right, so here we go. Negative 1 times 3. Add. Negative 1 times negative 10. Add. Negative 1 times 19. Add. Did I do my math right? I don't know why I always make mistakes when I do this. Does that look okay? Don't just copy mine down. Make sure you can do it, because mine might be wrong. So then what's the answer going to be? 3x squared minus 10x plus 19, and then we have a remainder of negative 18 over x plus 1. So you can say plus that if you want to. All right, one more synthetic division. Would you try this one on your own? I think there's enough room down there at the bottom. Wait, try this one on your own. Anybody want to come up and put it on board? Jill, great. Go ahead, put your division up here and let's compare it with everybody else's, see what we came up with. Why are you so sleepy today. It's Monday. Mondays are gonna be a seventh of your life. Don't waste a seventh of your life. What do you guys think about Gio's work? Thank you, Gio. What do you guys think about that? Does that look like what you have? Anybody match that? Sincere?
Where did you get 14?
I got the last part, I ain't get 9.
You didn't get 9?
I got -5 here, -1.
Yeah.
So when you multiplied 1 times -5, Gio, that would be -5. See when you multiply here? And so this is -1.
Oh, he put a 14 up there. That's why he got 9 instead of a 4.
That's 1.
No, his 1 was just, no.
Oh.
He had a positive, 4 and 5 made 9. He had that positive, but now it's negative, so I think it's okay. So does that look more like what you got? Everybody okay with that? All right, so now we are going to practice one of those problems where you have to guess. How will you recognize that? Because on test day, I'm not gonna say guess. How are you going to recognize that it is a problem that's gonna require guessing? Let me write one down here, and then tell me how you know. How do you know that requires guessing in order to factor it? Well, what's your other option? Well, no, PRRs are guessing. Your other option is factor by grouping. Does this appear to factor by grouping? It does?
No.
I saw some nods. I don't think this factors by grouping. Because again, it's not a matter of just being able to pull stuff out. It's a matter of having the same thing left over when you do. So this doesn't factor by grouping. So we are going to guess. All right. So who feels like you can come up and make a list of the PRRs? Just make a list of the PRRs. Who can do that? Kendrick? Yeah, come on up. Bring your notes.
I just said I
Come on, bring your notes. Pick a friend to help you. Phone a friend. You don't have any friends? Who do you want to help you? Does anybody know how to help Kendrick on this? This, Gio, I love you. You've already been to the board. Anybody else know how to do it?
I think Josh
Joshua, do you know how to do it?
I know to find the PR.
That's all you have to do.
That's all you
Help
gotta
him.
do.
That's all you have to do.
I can't switch it.
So he's gonna help him find the PRRs. And what should the rest of you be doing? Finding a place to write. This is not in your notes. This is an extra problem. This is an extra one. We're just practicing. So write it in the margin or get out another sheet of paper or something. So what are you doing here? Finding the factors of 12. So he's got 12, 4, 3, 2, and 1. Is that a complete list?
No.
6? Any order, just tack it on the end, that's fine. And what else is he missing? When we do the factors, it can be plus or minus. So stick a plus or minus out there. Well, out in front of the numbers, like right here. And then, you don't need to worry about this, because again, that leading coefficient is 1, but remember, your PRRs are over your leading coefficient. But since his leading coefficient is 1, he doesn't need to write that down if he doesn't want to. Okay, good work. So Kendrick, next time, you know how to get the PRRs, right? Factors of 12 over factors of 1. Okay? All right, who knows what the next step is? Now that we've made our list of possible guesses, what is our next step? We gotta guess, right? And when we guess, we will divide. So, Dave?
I will solve it.
Yeah. Let's go. Good job. Do you need help, or you gonna fly solo with it?
I think I got it.
I got it.
Go ahead and do it. I mean, it's just-
Sure. Oh, did you already try some?
Yeah.
That's okay, that's all right. So I don't know, was that your first guess, or did you
Yeah.
guess? Oh, okay. So his first guess was 4, which is in the list, right? That's the key. Pick one from your list. He picked 4, and he says it works. Oh my golly, gee whizzikers, it did work, super. So, what does that mean? He has found one of his dots. So he's taking the leftover down there, x squared minus 2x minus 3. And what are you gonna do with that? Yep, he's gonna try to factor it. Not that one. 3 times what's gonna give you 3?
1.
Yeah, there you go. Beautiful. Somebody's been paying attention, God bless you, my friend. Now, the purpose of the problem was to graph. That's what we were doing. So, we've got it all done. We're ready to actually sketch it now. So can anybody do that based on everybody's work here? Can anybody sketch it? Okay, Elijah, come on up. You wanna bring a friend? Okay, here we go. Now, we're gonna put the dots, on the number, or on the graph, so where are your dots gonna go? We're gonna have one at 3, and one at -1. And then there's one more. Where does that other dot go? At 4. Remember, Gabe's guess? Yeah, remember that? It gave us a remainder of 0, so that means there's a dot. Okay, let's label those points. So -1, comma 0. 3, yep, and 4, perfect. Yep, it sure does. Every cube's gonna start down there. Beautiful! House come. There are no bouncing around like there were in our last couple of examples. We didn't have any squares. Okay? Alright, okay, that's it. That's enough. You guys can now go ahead. You got a couple homework assignments to work on. So maybe I'll just